All right, it's time to get ready for our Unit 1 test. And so the first part is just graphing these functions. And so f of x equals the absolute value of x. This is our parent function. It hasn't shifted any direction. It's the normal. And so we're going to start at 0, 0 at the origin. And because there's nothing in front, we're going to go up 1 over 1 in both directions. So here's the absolute value parent function that makes a v. The domain for every single absolute value function is going to be all real numbers. It goes forever to the left and forever to the right. The range on this one is everything greater than or equal to 0. This one has a lowest value, so a minimum value of 0. The symmetry cuts right here down the y-axis, x equals 0. It's got to have x equals. On this side, we're decreasing. On this side, we're increasing. Here's negative infinity over here, positive infinity over here. The breaking point's at 0. And so we're going to be decreasing from negative infinity to 0, and then increasing from 0 to infinity. This has an x-intercept at 0 and also a y-intercept at 0. That's where it crosses the x and y axis. Number 2. X minus 2 is going to go to the right 2, plus 3 goes up 3. So 1, 2, 1, 2, 3. And then because of the negative in front, it's going to reflect over the x-axis. It's going to go down instead of up, and the 1/2 means down 1 over 2. So we're going to go down 1 over 2, down 1 over 2, down 1 over 2. On the other side as well, 1, 2, 1, 2, 1, 2. And there's the v. Again, domain's gonna be all real numbers. And if you wanted to check your graph in the calculator, just to go through this process as well, inside of our y equals, I'm gonna put negative 1/2. I'm gonna go math to the right to absolute value, x minus 2, and then plus 3. And we can click graph. It should look like my graph, which it does. I could also go into the table and check some points. So I had 2, 3, which this has 2, 3, and so we're good. My range is y is less than or equal to the y value is 3, has a maximum point of 3. On this one, it's increasing over here. As I go left to right, it's increasing, and then it's decreasing. The breaking point is right here where x equals 2. So it's increasing from negative infinity to 2 and decreasing from 2 to infinity. In symmetry, x equals 2. On number 3, doesn't move left or right at all, just down 4. So 1, 2, 3, 4. And this one has a 3 in front, so we're going to go up 3, 1, 2, 3 over 1. 1, 2, 3, 1, 2, 3, 1. Same thing on the other side. 1, 2, 3, 1, 2, 3. Again, domain's gonna be all real numbers. My range, the lowest point is -4, so y is greater than or equal to -4. This one again has a lowest point, a minimum of -4. The symmetry is x equals 0. And so again, here's my 0, negative infinity, positive infinity. On the left side, it's decreasing. On the right side, it's increasing. So decreasing negative infinity to 0, increasing 0 to infinity. All right, going on to the back. Number 4, one more graphing problem. And so on this one, we're going to be going to the left 4 and up 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. Because the negative in front, we're going to be going down 1 over 1. And so there's the graph. Again, domains can be all real numbers. On this one, the highest point, the maximum point is 5. So my y is going to be less than or equal to that 5. My symmetry is x equals -4. and we're increasing over here and decreasing over here. And so increasing is going to go from negative infinity to negative 4, and decreasing is going to pick back up at negative 4 and go to infinity. Start with the graph f of x equals absolute value of x. We want to stretch it by a factor of 2. That's going to mess with the slope and shift it 4 units to the right. So my new function is going to have a 2 in the front, and to make it go right 4, we'll put x minus 4. Start with the graph, absolute value. Has a domain of all real numbers, that's everything, a range of negative 3 to infinity. And so to be negative 3 to infinity, if we want to draw a picture, the starting point has to be somewhere on this dotted line down here. So it could be here and going up, but it's going up to infinity. It could be here and going up. It could be over here and going up, somewhere on this line. So two things need to be true. One, to make it go up, I need to see a positive number in front. It doesn't matter what number, you can put any number you want or no number at all. It could be a 1 right there. Inside the absolute value, it doesn't say anything about left or right, so you could have plus or minus any number inside. And then at the end, to make it go down to negative 3. And so that's important and that's important. These other things can change. Number 7, lists all transformations. And so this 0.75, that's going to be a vertical compression because it's between 0 and 1 by 0.75. X minus 7 is going to go right 7 and up 4. The negative in the front is going to reflect over the x-axis. The 3 is going to be a vertical stretch. X plus 1 is going to go left 1. And minus 9 is going to go down 9. And now for solving. And so again, we have to isolate the absolute value, split it, and solve it. So this one is already isolated, so it's time to split it. X minus 4 equals 12. X minus 4 equals negative 12. And then we'll add 4 over. So x equals 16. We'll add 4 over. So x equals negative 8. And it's always helpful. We can check our work by plugging it in. And so in our calculators, we can just go in here and press math, absolute value. 16 minus 4 equals 12, good. And then we'll do it again. This time we'll do negative 8 minus 4, also equals 12. So both of them checked, we're good. All right, so on this one we're going to subtract 4.4 first. So negative 0.3, absolute value of x plus 2.5 is equal to, let's do 12. And then we're going to divide by negative 0.3. So absolute value of x plus 2.5 is equal to negative 40. And because we have the absolute value by itself and a negative on the other side, that's going to be a no solution. All right, moving on. Number 11. We'll start by subtracting 12.5. So 4, absolute value of x minus 2.5 is equal to 0. We'll divide by 4. So x minus 2.5 is equal to 0. With 0, you can't split 0, so this one's only going to have one answer. And we'll add that 2.5 over to get x equals 2.5. And then again, I can check that in the calculator by doing just this. I mean, honestly, I don't even need to put it in the calculator, but if I plug in 2.5, that equals 0. 4 times 0 is 0, plus 12.5 is 12.5, so that checks. Number 12, it's already isolated, so we're going to split it. We'll add 4 over and divide by 5. We'll add 4 over, divide by 5, and then we can check it. So in our calculator, math over 5 times 4 minus 4, 16, check. Math absolute value, 5 times negative 12 divided by 5 minus 4 equals 16, check. All right, and this one will add 9 over 3. Absolute value of 2x minus 6 is less than 18. We'll divide by 3. So 2x minus 6 is less than 6. And then that's the absolute value, so we also have to do 2x minus 6 is greater than negative 6. And now we'll solve. And so we'll add 6 over. 2x is less than 12. And we'll divide by 2. X is less than 6. We'll add 6 over. We'll divide by 2. So those are correct. X is less than 6. Also, x is greater than 0. It could also be written like this. This one's already isolated, so we'll split it. X minus 2 is greater than 3. X minus 2 is less than negative 3. We'll add 2 over. X is greater than 5. We'll add 2 over. X is less than negative 1. This one's an or statement because they're shading opposite sides. On this one, we'll subtract 12 to get 3. Absolute value of 2x minus 4 is less than or equal to negative 6. We'll divide by 3. 2x minus 4 is less than or equal to negative 2. Now that we have a negative on this side, we're done. I don't need to do any more work. Can a positive number be less than a negative? No, that's a no solution. We'll divide by negative 4, divide by negative 4, and so x plus 2. Because we divided by negative, that sign's gonna flip, negative 4. Again, we have an absolute value by itself and a negative, so we're gonna stop. Can a positive number be greater than a negative? Yes, for all real numbers. We'll subtract 5. We'll divide by 5. And then I will split it. And so 2x minus 4 is greater than or equal to 2. Also, 2x minus 4 is less than or equal to negative 2. We'll add 4 over. Divide by 2. X is greater than or equal to 3. We'll add 4 over. 2x is less than or equal to 2. Divide by 2. X is less than or equal to 1. We'll add 4 over. 2/5. 5x plus 7 is equal to 56. And then to get rid of this fraction, we'll multiply by the reciprocal, which is 5 over 2. 5 over 2, so it gets rid of that. And so we'll just go to the calculator. 56 times 5 over 2 gets 140. And then we'll also set it equal to the negative. We'll subtract 7. And then we'll divide by 5. You can do the fraction or the decimal. Again, we'll subtract 7 and divide by 5. And we can check it. And so on this one, we'll do alpha x 2 over 5, absolute value of 5 times 133 over 5 plus 7 minus 4 equals 52. And then I'll just copy that one down here and change the fraction to be negative 147 over 5 equals 52. Check. There's my work on the calculator. For the equation, are the solutions negative 2 and 2? We could plug it in and check, or we can just solve it and check. Either way works. I'm gonna go ahead and just solve it, just so I know what the answers are. So, or actually I'll plug it in. So for the first one, if I were to plug in negative 2, absolute value, absolute value of negative 2 plus 7 minus 1 is 9. So negative 2 checks. Now I'll do the same thing. I'm just going to take out that negative by deleting it. That one does not check. And so now I want to know what the actual solutions are. So I'm going to go ahead and add 1 over. And so 2x plus 7 is equal to 10. We'll divide by 2. X plus 7 is equal to 5. X plus 7 is also equal to negative 5. And then we'll subtract 7. So x is equal to negative 2. X is equal to negative 12. There's the correct answers. And that completes our review. And so let me know if you have any questions, and hope you get ready for Thursday.